Okay, so I know a lot of you are interested in this part. This is nuclear power. I know we were talking about nuclear power quite a lot at the start of this topic. So nuclear power is one of the major sources of energy in many countries, and it's becoming more and more popular. Nuclear power stations use radioactive elements such as uranium and plutonium. Although they are non-renewable sources, you need to remember that they are non-renewable, they are relatively plentiful in supply, and you can get an awful lot of energy from just a very, very tiny amount of these materials. Nuclear power stations, however, they do produce dangerous radiation and waste products that are difficult to dispose of. Quite often they're buried in concrete or at the bottom of a lot of water. Otherwise, you might get irradiated. So nuclear power stations do not produce greenhouse gases, though. Okay, so they're dangerous in other ways. Nuclear energy is released when changes take place right in the center of the nucleus of an atom. Okay, so you might have done atoms in chemistry, but you might not have. That's why I'm going to go through the basics of an atom. So everything is made up of atoms, so tiny building blocks that make up everything in the world, the universe. And at the center of each atom, there is what we call a nucleus. Now, please don't get mixed up between nucleus of a cell and nucleus of an atom. They are different things, but they just mean that right in the center. The nucleus contains two types of particles. So the nucleus has got two types of particles in them. One type are called protons, and one type are called neutrons. And around the outside of that nucleus, there are electrons just sort of dancing around the outside in a big circle. Okay. So here is a diagram of an atom. So you can see right in the middle here we've got the nucleus. So I'm going to label that nucleus. And inside, it doesn't matter which colour you choose, there are protons. We'll say that the sort of white ones are protons and the grey ones are neutrons, but they're both the same size, so you can't really tell unless you are told what they are. And as I said, around the outside, we have electrons. Okay. Sometimes you might have seen, especially if you've watched like Big Bang Theory or something like that, you've got sort of your nucleus in the middle, and then you quite often see them drawn like that. Those sort of semicircles are just where the electrons might be as they're spinning around. So when a neutron, so we can sometimes have neutrons that are outside the nucleus, and we can fire them. And when the neutron collides with the nucleus of a radioactive, so that's something that's unstable atom, the nucleus splits in two, changing nuclear energy into heat energy. Okay, so that process of splitting in two produces heat energy. So we've got this neutron that we've fired in just on its own. This is the nucleus of a radioactive atom, and this is it splitting, producing heat energy. And it splits into two smaller nucleuses, but also fires out some extra neutrons. Okay, and those extra neutrons can then go and hit more nucleuses, which will then split and produce more heat energy. So when a nucleus splits, it also produces more neutrons, which can go on to split more nuclei, and we call it a chain reaction because when one thing spurs on another thing, basically. Chain reaction. So you can see here a diagram here. So start off with one nucleus here, and then that splits into two. That splits that nucleus, sorry, one neutron, I should say. And that splits that nucleus into two, which also fires out some more neutrons, and they go on and split nucleuses. And then those neutrons go on and split more nucleuses. And that one also splits on a nucleus, but we can't fit it into the diagram. So you see it gets more and more nucleuses are split, and more neutrons are fired out. And if we don't control it, that will go kaboom. Okay, it will produce so much heat energy, it will be basically a nuclear bomb. So in nuclear power stations, obviously we need to control it, and we have lots of We sometimes have things that slow down the neutrons. We have things that can take neutrons out of the process, so we don't have as many splitting up, not as much heat produced. We also have ways to cool them down as well. So here's a nuclear power station, and the energy changes in a nuclear power station are nuclear energy inside the nucleus, sorry. Then that produces heat energy. And then that heat energy, then we have the same kind of thing that happens in every power station. So the heat energy heats water, produces steam, which turns a turbine, which then turns a generator, which produces electricity. So the nuclear to heat energy is in the reactor. Then we have the kinetic energy and the electrical energy, which happens outside of the reactor in a turbine and a generator. Okay. So what I'm going to get you to do is do some of this, find out a few things about the Chernobyl or the Fukushima nuclear accident. Now these were quite a while ago, and nuclear power has moved on since then, so it's a lot safer, but it is quite interesting to read about it. So what I'd like you to do is think about the Chernobyl or the Fukushima nuclear accident, one or the other, and find out why did the accident happen? What were the consequences of the accident? And should we, in your opinion, stop using nuclear power because of the accident? Now, there's no correct answer there, but I'd just like to know what your opinion is.